All right, let's take a look at a geometry problem that seems pretty straightforward on the surface, but it's actually a fantastic little puzzle. We're going to crack this thing open like a case file, and you might just be surprised where the final clue has been hiding. Okay, let's get into it. So here it is, our case file, if you will. You've got two circles and one small green square. The question is simple. What is the area of that square? Now, it really looks like we don't have enough information to solve this, but trust me, everything we need is staring us right in the face. The secret is all about seeing the hidden connections. So here's our mission. We need to find the area of that little green square, and we can only use the information we can see. That's it. No tricks, no hidden numbers, just some good old-fashioned geometry. You know, any good investigation starts by laying out the facts, so let's look at our clues. First off, these two circles are identical. We also know that the radius of each one is exactly 4 centimeters. And then there's our target, the square, and you can see it's tucked perfectly into that little space. The goal? Use these facts to find its area. Okay, the key to cracking pretty much any geometry puzzle is to reveal what's hiding in plain sight. So we're going to add just a few simple lines to this diagram, and when we do, we're going to uncover a shape that holds the entire solution. Let's start building this out. First, we'll drop a vertical line from the center of each circle straight down to that baseline. Now, since these lines are just the radius of each circle, we know for a fact that they each have a length of 4 centimeters. All right, next step. Let's draw a straight line connecting the two centers. Because this line is made up of the radius from the first circle plus the radius from the second one, its total length is just 4 plus 4, which gives us 8 centimeters. So far, so good? And here it is. This is the master stroke. By adding just one more line, we've created a perfect right-angled triangle. This right here reveals the hidden structure we've been looking for. This triangle. This is the key that's going to unlock everything. So, now that we've found our hidden shape, we need the right tool to actually use it. And when you're dealing with a right-angled triangle, there is one timeless, incredibly powerful tool that mathematicians have been using for, more than 2,000 years. And here it is, the Pythagorean Theorem. This is our master key. It's beautiful in its simplicity. It just says that for any right-angled triangle, if you take the lengths of the two shorter sides, call them A and B, you square them and you add them together, that sum will equal the square of the longest side, C, which is called the hypotenuse. A squared plus B squared equals C squared. It's elegant and it's exactly what we need. Okay, it is time to bring it all together. We've got our triangle and we've got our theorem. Now we just need to apply the key to the lock and see what we find. Let's break down how it's done. So how does this theorem actually crack the case? Well, let's focus on that smaller right triangle that's hidden inside the diagram. Its longest side, the hypotenuse, is just the radius of the circle. So that's easy. It's 4 centimeters. Now, the two shorter sides are the crucial part. Their lengths are directly tied to the side of our unknown square, which we'll just call S. One side's length can be described as 4 minus S, and the other is S divided by 2. And here's the magic. When you plug those into our master key, A squared plus B squared equals C squared, you get a single equation where S is the only thing left to solve for. The geometry just pins the answer down for us. So after we construct our triangle, and we apply the master key of Pythagoras, and we run the numbers, we have our answer. The case is just about closed. So it all comes down to this. After all of that geometric detective work, what is the final area of our little green square? 2.56. That is it. The area of the square is 2.56 square centimeters. A clean, beautiful number that was hiding inside that triangle all along. But hang on a second. Do you remember what the source for this explainer was called? The source, chronology 256. That's right. The answer was literally hidden in plain sight from the very, very beginning. What a perfect little twist to a perfect little puzzle. And you know, it really makes you wonder, doesn't it? What other elegant secrets and hidden connections are just waiting for us to find them inside the simple shapes we look at every single day?